Okay, so this is the solutions video for the Crack the Circuit game. In the first level, we have a light bulb, and there's not really anything you can do. It's really just to practice building a circuit. So battery, and if we make a complete loop, a complete circuit, then we will light the light bulb. In the second level, they've introduced a switch. We can see that when we put the switch on, the light bulb goes on. That must close the circuit. And that's all there is to this one. So let's add a switch. We can put it anywhere in line, and then I can put the light bulb somewhere in the same circuit. Oop, I moved it by accident, that's okay. So now I've made the circuit. When I flip the switch, it closes the circuit, the light bulb comes on. Okay, two light bulbs now. You can see they're both a little bit dimmer than they were before. And when I lift one, it opens the circuit. So either one gets lifted and the circuit gets open. So that implies all these details tell us that these things are in series with each other. When we're in series, the voltage is going to be shared across the two light bulbs, and therefore each light bulb gets a little bit less of the voltage or the energy from the battery, so they don't glow as bright, they glow with less power. And when I lift either one up, it opens the circuit. So they must be in series with each other. Now these two, we can see that they're both glowing brightly. And when I lift each one, they don't affect the other. So that implies that they must be in parallel. When things are in parallel, they act as if they're on their own separate loops, their own circuits. So the first light bulb is going to act like it's on its own full circuit. So it's going to get the full voltage from the battery. That's going to make it have more power and glow more brightly. The second one also acts like it's on its own loop. And those two loops are independent of each other. So when I lift one light bulb, it doesn't open the circuit for the other light bulb. Okay, we've got two light bulbs. When I flip the switch, they both turn on. I can also see that they're a bit dim. So that suggests probably going to be in series because they're sharing that voltage across the two bulbs. And it's confirmed when I lift each light bulb, it opens the circuit for both light bulbs and they go out. So this suggests that there is now a switch, but that the switch is in series along with the two light bulbs. So if I put one light bulb there and one light bulb there, or anywhere along the series path, they need the switch to go on, and if I lift either one of them, they turn off the other light bulb. So they're all in series with each other. Okay, now in this one I see the light bulbs are off. When I turn the switch, they both go on. I can see they're both glowing brightly, which implies that they are getting more voltage and more current, so they're getting more power, they're burning more brightly. So I'm already thinking maybe in parallel, and I get that confirmed for me. When I lift each one up, it doesn't affect the other one. So they're both affected by the switch, but they're not affected by each other. So the switch needs to be in series with both light bulbs. So that means I'm going to put the light bulbs on separate paths, but both of their paths have to go through that switch. So that way the switch will affect whether or not the circuit is open, right? If I open it, both of them go off, so the switch needs to be here. So we would say the switch is in series to both light bulbs, but the light bulbs are in parallel with each other. Okay, moving on to level 7. In this one, this switch does nothing, this switch does nothing, but both switches make the light bulb glow. So that means that everything is in one path, is in series. Both of the switches are crucial to the light bulb lighting, so they must all be in one big loop, and I have to click on both switches to make the light bulb light. Okay, level 8. So this light bulb is glowing regardless of the switch. When I close this switch, the other light bulb glows. If I lift this light bulb, it does not affect the other one. If I lift this light bulb, it does not affect the other one. Okay, so the light bulbs are clearly in parallel with each other because they don't affect one another when I lift them. They don't open one another's circuits. So I'm going to put the battery here, like I usually do. Now the difference is that the first light bulb, the switch does not affect the first light bulb, but there must be a switch in between the battery and the second light bulb because that one only goes on when I click the switch. Okay, number 9. Flip this switch, one light bulb goes on. I flip this switch, the other light bulb goes on. And when I lift them, they don't affect one another. So this implies that we've got in parallel light bulbs, and they each have their own switch because they aren't affected by one another's switches. So I click that one on, and the first light bulb goes on. I click that one on, the second light bulb goes on. So those are in parallel, and each parallel path has its own switch and light bulb. Okay, level 10, I've got 3 light bulbs. They're all glowing with rather dim light. And when I lift any of them, they open the circuit for all 3. So that means all 3 have to be in series with each other. So it doesn't matter where I put them in series. They must all be in series because of how they affect each other, how it opens the circuit when I lift any of them. Okay. Level 11, if I look at these, the bulb on the left is glowing brighter than the ones on the right. So that already is a suggestion that these two are sharing the voltage while this one is not. So these ones are looking like they're probably in series with each other, and they're probably parallel to this one. And we can test that. If I lift this one, it shouldn't affect the other ones because it's on its own path. These two, however, should affect each other because they appear to be less bright. That means they're sharing voltage. That means they're on the same path. Sure enough, when I lift them, they open the circuit for one another. So in drawing that, I'm going to make 2 paths. One path is just going to have 1 light bulb on it. That's that nice bright light bulb because it's the only thing on the path, so it's getting the full voltage, the full power. Whereas here, they must be on the same path. So the 2 light bulbs are parallel to the 1 light bulb, but the 2 light bulbs are actually in series with one another. Okay, now we've added some switches into the mix. I turn this one on and I get this light bulb. I turn this one on, I get those 2. Okay, so this first light bulb only affects this first light bulb, and this second switch affects the second 2. They are a bit dimmer, again, looking like series. They affect one another. These 2 light bulbs are clearly in series with this switch, so this is sort of one loop, and this one does not affect the others. So this switch and light bulb appear to be on a different path. So it's kind of like the last one, except we have to work a switch into each path. So here's my battery. There must be a switch for this first light bulb. When I click it, it turns that one on. And there's also a switch for these other 2 light bulbs, and when I click it, they go on. Level 13. 2 light bulbs. Nothing when I do the first one. That one does both. This one turns that one off. Interesting. Okay, so this one on the right, this switch appears to be in series with both light bulbs. So this is important for both of them to turn on. And then this one only opens the circuit for the second one. And when they're both on, just to double check, they're both really bright. They must be in parallel with each other. So I definitely have some sort of in parallel setup. The first switch is essential for both of them. The second switch is only essential for this second light bulb. So this switch on the right, which turns them both on and off, is this one. And this switch here, which only affects that second bulb, is this one. So it was a parallel setup, but it was tricky how they had the switches. The first switch was in series with both of them, so this first switch was essential for both paths, and the second switch was only essential for the second path. Okay, level 14. 3 light bulbs. Those are in parallel. Oh, but this one, okay, so they are glowing dim. That implies some sort of series setup because they're not as bright. So they're sharing voltage. I can see that this one cuts the entire circuit. So it's essential. There must be some main part of the circuit where this light bulb is because it opens the entire circuit. These 2, however, must be in parallel with one another because when I lift one, the other one still glows. So that means that there must be a light bulb that's sort of on the main path, and only after that light bulb do we switch, or do we split. So these ones are on their own paths because they don't affect one another. So this light bulb was the light bulb on the left that when I lift it up, it opens the circuit for everything and all the light bulbs go off. These ones, however, are the two light bulbs on the right, and they don't affect one another, so they must be in parallel. A new one, we've got a light bulb that's, this is level 15, that's glowing bright. This switch turns that light bulb on, and they don't affect one another, so they're parallel. This switch turns that one on, and they don't affect each other, so they're parallel. So it seems like I've got 3 parallel light bulbs, and 2 of them have switches attached to them, and one of them is just hooked up straight. This one in the middle is hooked straight up to the battery. So these other 2 require switches for them to be turned on. And that's how we get our 3 really bright light bulbs, each one getting the full voltage of the battery. Okay, 16. Interesting, the light bulb is glowing without the switch closed, and when I close the switch, it goes off. So what that means is that there must be a path that leads to the light bulb without the switch. So that's one path. Now, what is that switch doing? Well, if you give electrons, you give current an easier path with less resistance, they will always take the path with less resistance. So right now when the switch is open, this isn't a path for the electrons, so they have to go through the light bulb, so the light bulb gets the full voltage and current, and it glows brightly. When I close this switch, now the electrons can go through the outer path, which is easier than trying to push their way through a light bulb, which is something that has higher resistance. So the wire has very low resistance, so they will take that path, and that will short circuit the battery. It's also going to not allow any light to glow, because none of the electrons are going to go to the light bulb. So you can see it lit it up in red, gave you that short circuit, basically said, do not do this at home. But this shorts it out, and so the electrons take the path of least resistance, and they don't go to the light bulb. Okay, level 17. All right, we've got 2 light bulbs. They're glowing rather dim. They're probably in series in some way. When I turn this one off, then I only get 1 light bulb glowing, and did you notice that it also got brighter? So they can't entirely be, they're sort of in series with each other. If I lift this one, they both go out. If I lift this one, they both go out. So when the light is open, or when the switch is open, they are in series because they clearly affect one another. So that's my first little clue, is they must be in series. So I'm going to start there. They're in series with each other I know that because when I lift them, they turn each other off. But when I flip this switch, now the first light bulb is still burning, the second one is not. So that implies there must be a second path, and when I close it, it allows an easier path for the electrons. So they always take the path of least resistance. If they don't have to go through 2 light bulbs, they won't. They'll only go through 1. So by giving this second path, when I close the switch, now the electrons will just go through this light bulb. They'll take this shorter, easier path back, and this light won't get any of the electricity, any of the voltage. And so this one now is by itself. It'll get all the voltage from the battery, and it will glow brighter. Okay, last level, level 18. Okay, 1 light bulb. When I close this, I see nothing. I close that, I get nothing. Okay, so this switch is needed to close the circuit and make this light bulb glow. This one turns it back off. Okay, so that means I've got a light bulb here, and let me move it down. And there's a switch that goes to that light bulb. But there must also be another switch, and when I close that switch, it gives an easier path. It doesn't matter that it's a shorter path, it just is a path of less resistance. So right now, this turns on the light bulb, which is what I see with this one. But when I close this, it's going to give the electrons an easier, lower resistance path, and the light bulb won't be on it. So there must be this extra path that short circuits everything. And those are all 18 levels of the Crack the Circuit game.